Yeah, hi. Hello everyone. So this is regarding the post-contest discussion for Codeforces Round 961. So let's start with the discussion. The first question is diagonals. Let's go through the problem statement. So Vitali 503 is given a checkerboard with a side of N and K chips. He realized that all these K chips need to be placed on the cells of the board and no more than one chip can be placed on a single shell. So let's denote the cell in ith row and jth column as I, j. Then a diagonal is set of cells for which the value of I plus j is the same. This is how they have defined the diagonal. So for example, cells 3, 1, 2, 2, 1, 3 lie on the same diagonal because the values of I plus j for them are all same. But 1, 2 and 2, 3 do not. So a diagonal is called occupied if it contains at least one chip. So even if a diagonal contains at least one chip, we call it as an occupied diagonal. So you need to determine that, first of all, you need to fill all these k chips in this checkerboard. So after that, you need to determine what is the minimum possible number of occupied diagonals among all placement of k chips. So you are placing all the k chips on the board. After that, you need to determine that what is the minimum possible number of occupied diagonals that minimum number of diagonals that will be occupied. Okay. So like in the input, you have the number of test cases. You have two integers n and k. N is the size of the square, side length of the square, and k is the number of chips that you need to place. Okay. So let's see how we can do this. Let's first understand the question once more. So question says is, let's suppose the value of n given to you is 3. This means that you have a 3 cross 3 checkerboard. Okay. You have checkerboard something like this. Now I tell you that I want to place, let's suppose, uh, two chips in it. Okay. Now, first of all, let's identify the diagonal. For that, let's write for each cell what is the value of I plus j. For these rows are row number 1, row number 2, row number 3, and the columns are column number 1, column number 2, column number 3. So if we simply write the value of I plus j, let's see what we get. The value of I plus j for this cell is 1 plus 1, which is 2. The value of I plus j for this cell is 3. For this it is 4. For this it is 3, 4, 5. For this it is again 4, 5, 6. So now, are you able to observe that what is actually the diagonal is? How the diagonal was defined? The diagonal was told to have the same value of I plus j. So can I say that this is my diagonal? This is my one of the diagonal. Again, this is my one of the diagonal. This is also a diagonal. This is also a diagonal. And this is also a diagonal. Can I say this? Can I say this? Isn't it? I can. Yeah, I can. So, so now the question is that I need to place two chips, isn't it? I need to place two chips. I can place it anywhere on the board. But the second aim is that the minimum number of diagonals should be occupied. Now just tell me, if I place one chip over here in this cell and one chip in this cell, then how many diagonals are occupied? There are two diagonals occupied, right? There are two diagonals that are occupied. But, if I place one chip over here and one chip over here, now just tell me how many diagonals will be occupied? Only one diagonal, right? So which one should I opt for? My aim is that the minimum number of diagonals should be occupied. So which one should I opt for? I should opt for this particular case, right? So now can you think of some greedy idea to solve this question? Are you all able to identify that greedy idea? Just observe one thing, that every cell is a part of a unique diagonal. Every cell is a part of some diagonal and every cell is a part of unit diagonal. This particular cell is a part of only this particular diagonal. This particular cell is part of only this particular diagonal, and so on. So every cell is a part of a unique diagonal. So what I can do is just observe when the side of the square was 3, there was one diagonal that contained 3 cells, two diagonals that will contain 2 cells. This diagonal and this diagonal are containing 2 cells, isn't it? And there will be 2 diagonals that will contain 1 cell. And similarly, if the value of n is 4, you will observe that there will be one diagonal that contains 4 cells, two diagonals that contain 3 cells, two diagonals that contains 2 cells, and two diagonals that will contain 1 cell. So this is the pattern. So what you will do now? You will greedily fill the cells. What is your aim? Your aim is that minimum number of diagonals should be occupied, and you know that even if a diagonal contains at least one chip, we say that the diagonal is occupied. So now if I tell you that for this particular case, let's suppose I tell you that I want to fill 5 cells. So what you will do? First of all, you want to fill 5 chips. So what you will do? First of all, you will fill all the chips of this particular diagonal that is containing 4 cells. So now the number of chips, so this diagonal is filled, and the number of chips that are left to be filled is only 1. So you can now fill it to any of the diagonals. So your answer will be 2. That is, there are 2 diagonals occupied. But in case you would have not filled this particular diagonal, and if let's suppose you would have opted for this particular diagonal at first, then in that case, even if you fill this particular diagonal entirely, 2 chips will be used. Again, if you fill one more diagonal, since there are 2 diagonals of 2 cells. So again, if you fill it again, so again one more 2 chips will be occupied. And now if you fill it with, let's suppose this, and now you just place your chips in this particular diagonal that is containing 3 cells. So one of the cell will be occupied, but the diagonal will be said to be filled. So in that case, the number of diagonals that is filled is 3. So what is our aim? Our aim is that we will start filling our diagonals from the ones that contain maximum number of cells. And how many diagonals we have of how many cells, that is clearly identified. There will be one diagonal of n cells, and there will be 2 diagonals each of n minus 1 cells, n minus 2 cells, up till 1 cell. There will be 2 diagonals each of these. So we will greedily fill the cells from the top and see that what is the minimum number of diagonals that are occupied. So yeah, that's the logic for this question. Let's jump to the code. So this is the code. So first of all, we are taking inputs of n and k, that is the size of the checkerboard and the number of chips that is need to be filled. We initialize our, let's forget this thing for once. You initialize your temp with n. Okay, temp is basically the number of temp is basically the initial number of cells in the diagonal. So that is, since we have started filling from the diagonal one that is containing the maximum number of cells. So how many cells it is containing? It is containing n cells, right? So we initialized our value with temp. Now, if the value of k is 0, that is the number of chips that is need to be filled is 0. So we can simply return, we can simply print 0. That is, there will be no diagonals that will be occupied, right? Now, if the value of k is not 0, if the value of k is lesser than equals to n, now just observe one thing. Just observe one thing. How many cells the first diagonal was containing? N cells, right? So if the value of k is lesser than equals to n, we can fill all the chips in this particular diagonal, right? We can fill all the chips in this particular diagonal, and we will say that only one diagonal is occupied. So if the value of k is lesser than equals to n, we simply print 1 and return. And if it is not so, we simply subtracted n from our k, because we will fill first n chips in that particular diagonal, and then we will see what we need to do. So we subtracted our k with n and also decremented our temp, because we know that the first diagonal that we were filling contained n cells, and the next diagonal that we are going to fill will contain n minus 1 cells. So since we initialized our temp with n, so we simply decremented our temp, and also initialized our answer with 1, because we know that once we do this k minus equals n, this means that we have already filled one diagonal, right? So initializing my answer with 1. Now we are simply greedily filling the diagonals. So while the number of while temp is greater than 0 and k is greater than equals to temp, so we simply increment our answer because we know that we are going to fill a diagonal. And what are the maximum number of cells that diagonal contain? Temp, isn't it? So we simply subtracted our k with temp. Now, if k is lesser than temp, then we are breaking because we know that what we know. Wait a minute. Yeah, what we know. If we have a diagonal that is containing, let's suppose n minus, wait a minute. Yeah. So if we have a diagonal that contains n minus 1 cells, we know that there are two diagonals of this type, right? Now let's suppose this value of n minus 1 is 3. Okay, n minus 1 is 3. So we are filling a diagonal that contains 3 cells, and there are two diagonals of this type. We know. Now let's suppose the value of k that is left, that is the number of chips that are left, was 5. So what we will do? We will simply do 5 minus 3 now, for there are two diagonals that are containing 3 cells. So first of all, in the first cell, we will entirely fill it. So 5 minus 3 will become 2. So we are left with 2 cells. We are left with 2 chips, right? So now then we know the diagonal contains 3 cells. The diagonal contains 3 cells. It will not be completely occupied. So in that case, we are breaking. And after breaking, what we are doing? We are just keeping a check over here that if, let's suppose the value of k was greater than 0, that is the value of k was left. In that case, we are simply incrementing our answer. So this particular case will be handled there. Like you don't need to write this thing. If temp not equals to 0, you can skip this thing. You can simply keep a check that if the value of k is greater than 0, we can simply increment our answer. Because over here, if the value of k was less than temp, we were breaking, assuming that all the cells will be filled, all the chips will be filled in that particular diagonal only, isn't it? So we were simply breaking. So if the value of k is greater than 0, we can simply increment our answer. And we know that if the value of k is not lesser than temp, that is, it is greater than equals to temp, this means that since we know that of temp cells, we had two diagonals. One diagonal already we filled. Now it's time to fill the other diagonal. So we simply subtracted temp from our k and incremented our answer since one more diagonal is filled. And now for the next thing, and now for the next pattern, you can observe. Now the next diagonal which contains n minus 2 cells, right? Since temp is depicting that how many cells are there in the diagonal, so we simply subtracted temp with 1. So we did temp minus minus. Once we do this, we simply print our answer, that is the minimum number of diagonals that will be filled. Now again, the implementation may vary. You can choose your own way of implementation. It is something that I thought while coding it down, but the logic remains the same. This is the logic and this is the pattern, that there is one diagonal that contains n cells. There are two diagonals that contain n minus 1 cells, two diagonals that contain n minus 2 cells, and so on. And you are greedily going to fill the cells. You are greedily going to fill the diagonals. If that thing is clear, then the coding part entirely depends on yourself, that how you like to code it. Okay. You can take reference of this code, but again, it entirely depends on you that how you are trying to code it. Now let's move on to the next question. So the next question was B1. There were two parts, B1 and B2. So B1, bouquet, it's an easy version. So let's see what the question says. A girl is preparing for her birthday and wants to buy the most beautiful bouquet. There are a total of n flowers in the store, each of which is characterized by the number of petals, and a flower with k petals costs k coins. A girl has decided that the difference in the number of petals between any two flowers she will use in her bouquet should not exceed 1. Okay. So at the same time, the girl wants to assemble a bouquet with the maximum possible number of petals. Now, unfortunately, she only has m coins and she can't spend more. So what is the maximum total number of petals she can assemble in a bouquet? You have been given T, N, M, and then A1, A2 up till AN. Okay. So let's understand what the question says. The question is that you have been given n flowers. Okay, you have been given n flowers, and you have been given some coins. Okay, now the ith flower contains ai petals. Okay, and the cost of using this ai petal, is cost of using this ai petals is ai. It's written. Uh, yeah. So the number and a flower with K petals costs K coins, isn't it? So the cost of K petals is K coins. But there is one con. So what is your aim? Your aim is that you construct a bouquet with these flowers. You have only M coins. So the question is, what is the maximum number of petals that you can take? But there is a constraint. The constraint is that the girl has decided that the difference in the number of petals between any two flowers she will use in a bouquet should not exceed one. So, like for example, this particular flower contains 5 petals, and this particular flower contains 7 petals. In that case, you can't use both these flowers in the bouquet. So the only flowers that you can use in your bouquet are the ones that contains like the one flower is containing 5 petals and the other is containing 6 petals. One flower is containing 8 petals and the other is containing 9 petals, something like this. Or you can use all the flowers of 8 petals and not using any other flower. So these are something that is allowed. But you can't do something like this, that you are choosing a flower that is containing 10 petals and you are also using the flower that is containing, let's suppose, 12 petals. This is something that is not allowed. The maximum difference between the petals of the flowers that you are using, between the number of petals of the flower you are using is 1. So this is the constraint. So let's understand with the help of one test case as well. So you have been given this test case 5, 10. So five are a number of flowers are 5 and the amount of coins you have is 10 and the number of petals of flowers of each type are 1, 1, 2, 2, 3. 1, 1, 2, 2, 3. Okay. So now just tell me, what are the flowers you can use? What are the options that you have? So you can either use a flower that is containing 1 petal and 2 petal together. So in that case, the coins you will be able to spend is 2 plus 2, 4, 5, 6. 6 coins you can spend. Or what you can decide that, okay, I choose this 2 and 3. Again, since I have 10 coins, so I can take all of these flowers, and the maximum difference between the number of petals of these flowers is also 1. So in that case, the number of petals that I will be able to gain is 7. And also my cost will also be 7, which will be lesser than M. So in this case, the maximum answer that I can get is 7. And you can observe that 7 is the answer, isn't it? So how we can solve this? Okay, one thing that comes to every one of us, every one of our mind is that since we require petals from different flowers having maximum absolute difference in their number as 1, why don't we short this array that is containing the petals? Because we know that the one that is containing 1 petal will cost 1, containing 2 petals will cost 2, and so on. So why not just short this? Because once we short this, we know that we can take only either this combination or this combination or something like this. The things will become adjacent, right? So why not let's short this? So let's first short this. Since in the first test case, it was given in the shorted order, but it may not be given in the shorted order in some of the test cases. So let's short this. So we have these petals. Okay. Now, now what comes to your mind? Now, something that comes to your mind is that, okay, I decided that I will start picking petals from here. There can be any point now from where you will start picking petals. Like you have the limitation that the maximum number up to which you can go, if you start picking petals from here is this point. If you again start picking petals from this point, if you start picking flowers from this point, so the maximum you can go is up till this point. If you start from this particular point, so the maximum you can go is up till this point. Now you can go up till this point, right? if let's suppose I extend the example of my own, I take 1, 1, 2, 4, 3, 6, 7, 7. Okay. So now there are how many possible starting points? I can either start from here, 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 here. I can start from any of these points. If I start from this point, what is the maximum distance I can go? I can maximum at max go till this point, right? Because if I take 4, it is not allowed because the difference between 4 and 1 becomes 3. If I start from this point, again, I can go up till this point only. If I start from 2, from this particular flower, the maximum I can go is still here only. I can't take even 4. If I start from 4, the maximum I can, it is not sorted. Let me short this. Wait a minute. Wait a minute. Let me short this. So 1, 1, 2, 3, 4, 6, 7, 7. So now, if I start from here, the maximum I can go is till this point. If I start from here, the maximum I can go is till this point. If I start from here, the maximum I can go is till this point only because the next number is 6. That is not allowed. If I start from this point, the maximum I can go is till this. If I start from this point, the maximum I can go is again till this. And if I start from this point, the maximum I can go is till this. So there can be multiple starting points. So why not explore all the options? Why not just go to all the possible starting points and just look how many maximum flowers we can take? Now, how we can do this? How we can do this? By maintaining a prefix sum. Let me tell you how. 1, 1, 2, 3, 4, 6, 7, 8. See, let me first of all calculate the prefix sum. You will get the idea that why we are doing so. 1, 2, 4, 7, 11, 17, 24, and 31. Now, if I'm starting from this point, what I know that before this, what is the sum? Before this, the sum is 0, right? If I'm starting from this particular point. What is the maximum sum till where I can go? Since I am allowed to take, since I am allowed to spend at max M coins, so the maximum till where I can go is 0 plus M in this prefix array. So let's suppose my value of M was 6. So the maximum I can go is up till 6. That is over here, since we have 4, so maximum we can go till this particular point, isn't it? So I know that from this particular point to this particular point, what is the sum that I can easily calculate via prefix sum? And I can maintain one answer which is initialized to 0. I can simply make answer equals to max of answer comma this particular sum. For here, the sum is 4. So now my answer will become 4. But there is a twist. Let me tell you where. Um, let's suppose our starting point was here. Okay, our starting point was here. If we are starting from this point, so just tell me what is the maximum value that we can go in the prefix sum from this particular point. So before this, what was the sum? Before this, the sum was 7. So the maximum I can go if I am starting from this particular point is 7 plus m, which is equals to let's suppose, let me just increase the value of m for explaining you this example. Let's suppose the value of m was 11. Okay. So the maximum I can go is 7 plus m, which is equals to 7 plus 11, which is equals to 18. So my prefix sum array will tell you that if you are starting from this particular point, you can go till this particular point. My prefix sum array will tell you, because once I start from this particular point, my already I had the like my sum will start from 0, isn't it, from there? So I can take this particular petal, it will amount 4, it will cost me 4. I can take this particular flower as well, it will again cost me 6. 4 plus 6 is 10, which is still lesser than 11. So my prefix sum array will tell you that you can go till this particular point. Just my friend, just tell me, is this possible? Can you take both these flowers? The answer is again no, a big no. Why? Because the absolute difference between the number of petals in the flowers should be at max 1. So are you able to first of all identify that what will become wrong if we simply take this particular thing, the upper bound of this particular thing in our prefix array? Now, how to correct that? It's pretty simple. You are starting from 4, right? You have this vector. So you know the maximum index up till which you can get. So maximum index up to which you can go. Once you identify that particular index, that okay, this is index 0, 1, 2, 3, 4, 5, 6, 7. So this vector will tell you that the maximum till which you can go is index 4. Because if you are starting from 4, you can't take 6. So the maximum you can go, let's suppose stored it in index 1. So maximum you can go is still index 4. This prefix sum array will tell you that the maximum you can go is still index 5. You are starting from 4. This prefix sum array will tell you that the maximum you can go is still index 5 with this m cost. Now, to whom you will listen? To the index 1 or to the index 2? Just apply the common sense. You will listen to index 1, right? Because that is the major constraint. That is one of the constraints. So you will just simply keep a check that if index 1 is lesser than equals, if is lesser than index 2, in that case, the maximum index till which you can go, you are standing at I, so you can go from I to index 1, isn't it? But if this is not the case, so you can go from your starting point till index 2. This comes from the constraint of m, and this comes by the constraint of absolute value less than equals to 1. So this one should be handled first and then this one, isn't it? So yeah, this was the like logic behind this question. So you can simply calculate prefix sum. For this finding index 2, you can again apply a low upper bound. And even for finding this index 1, you can apply the upper bound and just code it down. So let's see the code, how it's working. So taking the inputs of n and m, taking the vector input, then shorting the vector, calculating the prefix sum, initializing my answer to 0. Now running over all the elements, because every element can be my starting element, right? So assuming that index I is my starting element. So just tell me, what is the maximum sum till which you can get? Like, what is this value? So we need to calculate this value, na? The maximum sum which we can get. The maximum sum till which we can go in our prefix array, isn't it? So how we will get this? If I is 0, so it will be 0 plus m. And if I is not 0, so it will be prefix of I minus 1 plus m. Because we are starting from this particular point. But our prefix array already have some calculated till this particular point, isn't it? This is the sum. So if we are starting from this particular point and we know that we can maximum take m petals, so in the prefix array, that particular value will be the already calculated value before plus m. So if I is 0, in that case 0, otherwise prefix of I minus 1 plus m. Now we calculate index 1. Index 1 over here is actually the constraint of that particular thing. Like index 1 is actually the constraint for the prefix array. So we index 1 is actually the constraint over here, the one that we have discussed for this vector v. So index 1 is upper bound all v of v of I plus 1 minus v dot begin. So I am calculating upper bound of v of I plus 1 and simply then doing idx 1 minus minus. So this index 1 will return me the maximum index up to which I can take in that vector. Now index 2 is for the prefix array. So in the prefix array, what is the maximum index till which we can take? So calculating that, and similarly the upper bound of temp and doing index 2 minus minus. Now if index 2 is less than I, that is I can't take any element, even the element that I am standing at, I can't take any element. In that case, I am simply continuing. Otherwise, I am just keeping a check. If index 2 is less than equals to index 1, this means that I can take till index 2. So in that case, answer is max of answer, comma, what is the sum from I to index 2, isn't it? So how we can get that? Prefix of index 2 minus, if I is 0, then 0, otherwise prefix of I minus 1. Once we do that, we will get the sum of values from I till index 2. And if we are not taking index, if idx1 is less than idx2, that is, we are not allowed to take till those many elements because of that absolute value constraint. In that case, we know that we can maximum take till index 1, right? So from I till index 1, we can take. So answer is equals to max of answer, comma, prefix of index 1 minus, if I is 0, then 0, otherwise prefix of I minus 1. So this is how you will get your answer. So it was actually a pretty, and you can simply print your answer. So this was actually a completely greedy idea that I am starting at every particular element, and from there I can see that what is the maximum I can take, isn't it? So it is actually completely a greedy idea involving a bit of binary search. Fine. Okay. So let's move on to the third question. So it said as bouquet hard version, but just mark my words. Once you listen to the solution, you will find that this was actually a more easier one. So a girl is preparing for a birthday. The question remains the same. Let me go to the question once. A girl is preparing for her birthday and wants to buy the most beautiful bouquet. There are a total of n different types of flowers in the store, each of which is characterized by the number of petals and the quantity of this type of flower. So a flower with k petals costs k coins. The girl has decided that the difference in the number of petals between any two flowers she will use to decorate her cake should not exceed 1. So the constant remains the same. At the same time, she wants to assemble a bouquet with the maximum possible number of petals. Unfortunately, she only has M coins and she cannot spend more. So the question is, what is the maximum total number of petals she can assemble in the bouquet? So let me just discuss what the difference between this question and the previous question was. In this question, what you are given that you have N flowers, and for every flower, you are given that what are the number of petals for that particular flower. That is, if let's suppose there is a flower, um, wait a minute. So you are given that what is the number, what is the flower, that is how many petals a flower contains. Let's suppose there is a flower that is containing 5 petals, and you are given that how many such flowers exist. So let's suppose you have 10 petals or 10 flowers of this type that is containing 5 petals. Then you will be given, let's suppose there is a flower that is containing 6 petals, and there are two flowers such like this that is containing 6 petals, and so on. So what is the difference? If this question would have been, if this example would have been given in the previous question, it would have been given something like this: 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5 10 times, and 6 2 times. So this was the previous question and this is the current question. That is the only difference. Okay. But what was the advantage in previous question? In the previous question, you had the array. Now, um, this value is of the order of 10 power 9. The quantity is of the order of 10 power 9. So if every petal is of quantity 10 power 9, and you know every flower is of quantity 10 power 9, and since you have been given that uh, the number of distinct flowers is 10 power 5, is of order of 10 power 5. So you can't construct array of size 10 power 9, right? If you try to write it something like this, then you will end up constructing an array of max size 10 power 14, and that is something not allowed, isn't it? So you can't apply the approach of previous question in this particular question. But there is a pretty simpler approach for this question. Let me discuss with you, and let me discuss how to think of this approach. Let's suppose this was the example. There is a flower that is containing 5 petals. The quantity of those flowers are 10. There is a flower containing 6 petals, and there are two flowers like this, and there is a flower containing 8 petals, and there are three flowers like this. And you have been given the maximum amounts that you can spend. So you need to determine what is the maximum number of petals that you can gather, and a constraint of that thing, that the flowers that you are choosing should not contain the absolute difference greater than 1 in the number of petals, isn't it? That constraint also exists. Now, tell me, I simply short this one again, okay, on the basis of the number of petals. Now, if I am taking 5, what are the options I have? Just try to think greedily. Just forget everything. Just clear up your mind. Forget the approach of the previous question and just try to think what you can do. Okay, I have a flower that is containing 5 petals. What are the options I have? I can either construct a bouquet by keeping this particular flower as many number of times I want. Yeah, there is a constant in M, but how much this constant allows, keeping that in mind, I can construct flower by that. Or I can construct a bouquet that is containing both type of flowers, flowers with 5 petals and flowers with 6 petals. Both is allowed, isn't it? Now, when I am using six, I am using this flower six. So what are the things I can do? I can either construct a bouquet that is only containing six, or I don't have seven over here, right? So since I took 5, 6 combination earlier, I am not going to take 6, 5 again. So this is the only possible combination I have. Now talking of 8, the only possible combination I have is that I construct a bouquet that is containing flowers having petals 8, isn't it? So why not do one thing? Just observe one thing. Just let's first of all handle that particular case whenever we are taking flowers of only one type, that is either containing 5 petals, 6 petals, or 7 petals. So since I have m amount of coins, and I tell you that uh, there is a flower that contains 5 petals. So tell me, what are the maximum number of petals that you can take? Let's say take some value of m. Let's suppose m is 70. Okay. And there is a flower that contains 5 petals. So how many flowers of this type you can take? 17 by 5, that is equals to 3, isn't it? You can take maximum 3 flowers of this type, but you are also given the maximum number of flowers of that type. This value is given to you, right? So let's suppose the maximum number of flowers of this type was 2. So you would not be able to take 3 flowers. You at max you can take 2 flowers. So if you are constructing a bouquet with only one type of flower, so for any AIth flower, if quantity of that type of flower is Qi, so the number of flowers that I can take is nothing but minimum of m by ai, comma qi. Do everyone agree with this? This is the maximum number of flowers I can take of this particular type. And how much petals will it contribute? It will contribute me. So we will simply do answer as max of answer, comma, take multiplied by the number of petals in each flower is, yes. So take multiplied by. Take is the number of flowers and the number of petals it contains is A. So this was the case when while I was taking a flower of single type in my bouquet. So that case is already handled. Now the case left is that when we are taking two flowers of different types. By different types, I mean the ones that are containing different number of petals. Yeah, their absolute difference will be 1, right? So let's suppose I have a flower 5 flower that containing petals 5, and the quantity of this is 3. Let's suppose we take 2. And I have a flower of number of petals as 6, and I have 4 quantities of these type. And what I have is, let's suppose I have that, I will take 2 examples. First of all, I am taking the value of m as 60. Okay, I am taking the value of m as 60, and I will take 2 examples. So in first example, I would simply take the number of petals, number of flowers containing 5 petals as 3. So in this case, just greedily fill it. Just greedily fill it. By greedily, what I mean, first of all, just fill the maximum amount of flowers I can take that is containing 5 petals. Since I have 16 coins to spend, so just tell me, what are the maximum number of petals that you can take? Maximum number of flowers of this type you can take. It is again that same formula, right? This formula, isn't it? So the maximum you can take is 60, minimum of 16 by 5, comma 3. So it will result to 3. So you can take all the 3 flowers. Once you take it, how much money you already have now? You are left with 16 minus 3 into 5 because this particular flower, you took 3 flowers of this type and every flower cost you 5 since they contain 5 petals. So you are left with amount 1. Now, when you come to this particular flower, can you take this particular flower? The answer is no. It will cost you 6, isn't it? You can't take this. Once you are done with this, once you're greedily done with taking 5 and taking 6, once you are done with that, just tell me one thing. Just tell me one thing. Now, what are the options you have? Since you first took flower containing 5 petal and then 6, now whatever cost you have, you will be left out with some cost or the zero cost. If the cost left out with is 0, that is good. If not, I can replace every flower that I took with 5 with a flower of 6. Can I do so? Can I do so? I can replace every flower. What I took till now? Till now, I have 3 flowers containing 5 petals and 0 flower containing 6 petals. If I replace this particular flower with 6, how much cost, how much more I would be able to spend, and how much more will my number of petals increase by? It will increase by 1, isn't it? So just I can calculate one thing, that what is the maximum number of these things that I can replace. How I can get that? It will be nothing but, like, first tell me how, if we are replacing the flowers containing 5 petals, so the amount cannot exceed the number of flowers I took of 5 petals, isn't it? So one number is 3. Okay, I can replace 3 flowers. The other number is, since I am replacing these flowers with the flowers containing 6 petals, so the quantity of number of flowers of these types should also be available. Na? Like, let's suppose the number of flowers containing 6 petals available was 2. So I would not have been able to replace all these uh, flowers containing 5 petals, isn't it? So it will be nothing but minimum of the number of petals I took of the number of flowers I took containing 5 petals, comma, the number of flowers containing 6 petals available, which in this case is 4, comma, just see one thing. Since I am replacing 6 with 5 with 6, I am getting an increment of 1. Now the cost that I am left with will be some m. Na? I will be left out with some cost. If my left out cost is 1, will I replace all these flowers containing 5 petals with flowers containing 6 petals? The answer is no. You can observe over here. I will replace only one flower, isn't it? I will replace only one flower. So minimum of the number of flowers containing 5 petals, comma, the number of flowers containing 6 petals, comma, the cost that I am left with. So this is actually the left out cost. If I do so, I will get that how many flowers I can replace, and then I will be able to reach to my answer. Let me take one more example and then the things will become clear. Let me take this example. Number of flowers containing 5 petals is 2. Number of flowers containing 6 petals is again 3. And the value of m I am having is 70. So what I will do, first of all, I will greedily take all the flowers I can take uh, from the ones that is containing 5 petals. So I know that the number of flowers at max I can take is 17 by 5. And the maximum I have in my store is 2. So minimum of these 2 I can take. So the minimum of these 2 is 2. This means that I can take 2 flowers containing 5 petals. Once I do so, what will be the cost I will be left with? The cost I will be left with is 17 minus 5 into 2, which is equals to 7. And I have already taken 2 flowers that is containing 5 petals. Now coming to this particular flower that is containing 6 petals. So what is the maximum number of these flowers I can take? It is actually minimum of again 7 by 6, 7 by 6, comma, the number I have in my store, that is 3. So this comes out to be 1. Okay, this comes out to be 1. This means I can take one flower that cost me 6, and now since I have one flower that cost me 6, and the cost that I will be left out with is 7 minus 6 into 1, which is equals to 1. I am left with one cost, and these are the flowers I have taken. Now, just tell me that number, that how many I can replace. That number will be minimum of, I am going to like replace this flowers containing 5 petals with the flowers containing 6 petals, right? To gain this, to lower down this value of m, because my aim is to make this value m as much closer to 0 as possible, because I want the maximum number of petals, that is maximum amount of spend, isn't it? So I will replace every 5 with 6. So how many I can replace is nothing but minimum of the amount of number of flowers containing petals 5 I have taken, because they are going to be replaced. So that is 2, comma, the maximum amount of flowers containing 6 petals I have in my store. So earlier I was having 3. I already used 1. So the amount I am left out with is 3 minus 1. That is equals to 2. Comma, since by each replacement I get an increment of 1, that is my cost reduces with 1. So the maximum I would like to replace is m. This m is actually left out with, isn't it? So in this case it is 1. So the maximum number that I am going to replace is minimum of 2, 2, 1, which is equals to 1. So I am going to replace one flower. Once I do so, I know my cost m will get reduced by 1. So my m will become m minus equals 1. So it will become 0. And I know what was my original m. My original m was 70. The final cost that I am left out with is 0. So answer is nothing but max of answer, comma, 17 minus 0. So which is 70, definitely, isn't it? So this is actually the approach I am going to follow. Pretty much the greedy approach. First of all, take all the possible flowers of containing 5 petals, then all the possible flowers containing 6 petals. And once you do that, you are now going to replace the flowers containing 5 petals with the flower containing 6 petals. And once you do so, the thing is done. And it was very much easy to think as well, because what you are, if there is a flower containing 5 petal and there is a flower containing 6 petal, so you would have something like this particular type of combination now. So either a 6 will be replaced by 5, or a 5 will be replaced by 6. This is the only two possible combination. Now greedily, first of all, I took all the 5s I can take. Greedily I took that thing. So this case got eliminated, that is replacing 6 with 5. That cause got eliminated. That thing got eliminated. Now the only thing was I can replace 5 with 6. And I handled it, because I know once I replace 5 with 6, I will get an increment of 1. I have m cost. So I know that how many 5s I can replace, and so on. Isn't it? So this is how you can solve this question. Let me turn you to the code so that the things get pretty much clear. So taking the inputs of n and m, constructing a map, because for each type of flower, I am just storing that what is the quantity in my map. So first of all, taking the inputs for the number of petals in each flower, and then taking the input of the quantity of such type of flowers. So taking in A, and in MP of V of I am storing A. That is for the flower containing Vi petals. This is the quantity. Okay. Then, as in the earlier question, we shorted our vector. So we will do the same over here as well, because the absolute difference should be 1. So I am just storing all something like this, 5, 6, 8, 9, 10, so that I get to know that if I am using 5, so the next, if 6 is available, it will be available to the adjacent right only, isn't it? So that thing I'm using. So initializing my answer to 0. Now the first case, what I am doing, first of all, I am taking that if I am taking a flower of single type, that is containing a single type of petal, so what is the gain I can get? So answer is equals to max of answer, comma, what is the number of flowers I can take containing Vi petals? It is nothing but minimum of m by Vi, comma, the ones I have in store, that is MP of Vi, and this is the quantity. And from this, what is the number of petals I will get? Quantity multiplied by number of petals in each flower, that is Vi. So once I do this, so I am done with when I am selecting a flower of single type. Now this for loop is the one when I am selecting a flower of two types. That is one containing 5, one containing 6, one containing 8, one containing 9, something like this, adjacent ones. So if v of I plus 1 minus v of I is not equals to 1, should I proceed with this case of I? Should I do that? If let's suppose I have my I is over here, 6. I don't have 7. And I have decided that this is the case when I am taking flowers of two distinct types. So should I proceed with this one? The answer is no, isn't it? I should not proceed with this one because taking only 6 is already handled. Taking only 6 is already handled. So I should not proceed with that. So if v of I plus 1 minus v of I is not equals to 1, I am simply continuing. This is the reason I shorted the array, shorted this vector, because shorting helps me write this statement, isn't it? Otherwise, I know that I have m coins to spend. How many coins, how many flowers of ith type I can take? It is nothing but the same thing, minimum of m by v of I, comma mp of v of I. And my temp, that is the cost, will get decrement by number of flowers multiplied by v of I. Now, how many flowers I can take of larger type, that is of containing v of I plus 1 petals? So it is nothing but minimum of temp by v of I, comma mp of v of I. And my temp will again the same thing. The quantity multiplied by the number of petals in each flower will get decremented by that. Once I am done with this, now what is my aim? I will replace the smaller ones with the larger ones. So what is the quantity with which I can replace? The quantity is nothing but minimum of temp. That temp is minimum of temp, comma, wait a minute. Yeah. Minimum of temp, comma, MP of V of I plus 1 minus larger. Temp is actually the cost that I am left out with. That is, in this case, the left out M. The left out M was 1. So we included 1 here. No? So that is actually temp over here. The left out 1. The next thing is MP of V of I plus 1. That minus larger. That is how many. Since I am going to replace the smaller one with the larger ones, I need to have a look that how many larger ones I have. So the larger ones I have is MP of V of I plus 1. That was I was having originally. And larger are the number of ones that I already used. So I am left out with MP of V of I plus 1 minus larger. Comma, the number of smaller ones that I used, because the smaller ones are going to get replaced with the larger ones. So I can't exceed that number, the replacement number with that smaller ones, right? So comma, smaller. So I know once these get replaced, so my amount will just decrease by C. So what will be my answer? My answer will be max of answer, comma, M minus, I was left out with temp, right? I was left out with temp. And C C is the number that I got that is going to replace. So now I will be left out with temp minus C. So this is the left out number. So what is the cost or what is the number of petals that I was able to obtain? It was M minus temp minus C. This was the number of petals that I was able to obtain, right? So we can just open it. So it is M minus temp plus C. So the same thing, M minus temp plus C. Answer, and took the max with answer. And at the end, we are printing the answer. So this was the approach for this question, and it was a completely greedy idea, isn't it? Completely greedy. So, and I would say it was more easier to think in comparison to B1. Okay. So I hope the thing is clear. The session went well. So yeah, thank you everyone for attending this. Bye.